Hey, and welcome back to a new installment in our game dev series. I did a few things off camera on this, nothing too major, but I went back to our tiles and I gave them a bit more of a round sort of edge to them. So like this bottom bit here is now full circle rather than this sort of rounded rectangle it used to be. I think that gives it a bit more character. So, sorry about that. Yeah, I think this is the way we'll look to make most of our tile sets in the future when we actually get to making some non-crappy tiles. I think that this more round sort of look is definitely a bit better. I also was sat here last night, and one of the things that we're missing from what we're doing is tests. When you write code, you generally write some tests, and the tests tell you that the code does what you expect it to do. And then as you change the code, if you change anything that breaks one of your previous assumptions, the tests go, no, you've broken this previous assumption and it don't work no more. And that just helps you stay honest, sort of thing, and stop one change from breaking something else. So I had a look around, and there wasn't much in terms of things that embedded nicely into the Loft 2D engine. So what I did instead was, what I did instead is late last night I wrote a small test runner. And there's a bunch of randomness in here. It's all hacky and a bit nasty. But what it does is it looks for everything in this folder, and any subfolders that has the name test underscore something whatever .lua. It looks inside and it finds any functions that are called test underscore something, and it runs them all. And if there's any errors in them, it tells us that something went wrong. So what we can do now is we can go like this, and then we get out a green dot for everything that is correct, and if we break one of these on purpose and we rerun it again, it goes nope. In here we have one failure, and then it shows us our failures, and okay, so this is the X is not set correctly. It tells us where it is, and we can come in here and go, oh, yeah, that's what's broken. And then we can go fix it in our underlying library. I also added a few extra methods to our library. So I added like this. I added the methods to get the angle of a vector. Where is that one? It's in here somewhere. Here we go. So yeah, this will get the angle of a vector. So if I call up our little graphics thing here. So if you imagine that we have our two axes here, and a vector is basically a point within this. So this is our x, and this is our y. So if we wanted something that would say, I don't know, 3 4, and our vector was like x equals 3, y equals 4, then what we're saying is this is the the actual vector. It runs from 0 to there, and the angle we're calculating is basically this one here. And then we also added a length method to get this value, which is the square root of the squared values of x and y, which is our trigonometry, high school trigonometry. So the hypothesis is equal to if that is a and b, then this is a squared times if that is c, sorry, then we have c squared is equal to a squared times b squared, which means that when we take the square root of that value, sorry, when we take the square root of the squares of these two values added together, then we get this length. Let's get rid of all that for now. But yeah, so that gives us a couple of length functions, and yeah, so we've now got tests. These should make sure that our vector class stays the same. I will start to slowly fill in some tests for the other classes, but we're starting to write code like a grown-up now. So where were we last week? Last week we worked on this animation class. One of the problems with the animation class was that the texture based, the lookup of like sub images within the texture that we use for our sprite. So we've got like 2 images here, and then our tiles is like 1, 2, 3, 4, another 4, another 4, another 4. So this is effectively 16 different images, but we're just batching them together into one big file. But we had a lot of redundant, like reuse of the same sort of logic between these two. So what I was thinking of, what I wanted to do is try and abstract that. So I think what we need is these things are both implementing something called a texture atlas, which is a dumb complicated name for an image that contains other images. So if we create a little module quickly, I will put the standard bits in there. Okay, so then we want a function m.new. We probably want a texture, and then a lot of the stuff that we've been doing in these. Actually, texture. Tile set. Yeah, so all of this stuff actually sort of belongs to the texture atlas itself, right? So we can have texture is equal to texture. And then I think we'll go over asset size. I think each of the images within the texture atlas, I guess, is actually a sort of subtexture or a game asset of some sort, right? We'll go again with the margin. And the spacing. I think we want to copy across a lot of the logic we have in our tileset class into this one, as this is where it should actually belong. So we'll also put the quads in here. And what was the name for this? This is crawler.engine.vector2. Okay. And then after this, we return set meta table self, and we set that to the meta table. And then that gives us a new texture atlas. We do have a bit of logic that we probably want to keep hold of, though. That is that we're going to want to grab the number of columns and the number of rows, and then we're going to want to build our quads up. But I think we'll probably we've been exposing pretty much all of the internals of these sort of classes. I think we want to probably expose less of that in the future. So let's we'll have our asset size like that. And then this is a texture atlas factory. And what are the properties on here? We have a param of, oh, hang on. Can we get this to autofill some of this actually? I think it should. There we go. Yes, this is our texture atlas. Our texture atlas factory, and we have a texture which is a love.texture. Asset size, which is a vector2. Vector2 and a vector2. And then we want to mark some of these as optional. So we put a little question mark after the name. Then what we're doing is we're telling the type system that we don't really need it to we don't really need it to keep track of we don't really need it to enforce that we're passing these values, and then we can use the defaults that we have here. We're also going to want to define our tech atlas class. We'll call it an atlas. this has fields. It's gonna have a texture. Sorry, it's gonna have a texture which is a love dot texture. A asset size which is a vector2. A margin which is also a vector2, and a spacing which is vector2 as well. So yeah, so now we've got our class here. And we'll fix some of this up because it's still looking at tile size. So yeah, so we'll create we create our quads. I don't think we want to expose the quads directly though. So I think what we want to have is a method that takes, we want self and index in there. And this is going to be so we're going to have an integer offset for the quad. And what we're going to return is a love.quad, and this let's call it quad. Actually, let's mix this up a bit. So rather than that, we're going to return all of the quads. We're going to do so via a method. This means that we sort of keep the internal quads array to ourselves. We don't sort of let anything else mess around with it. So in theory, the tooling should start firing errors if we try and access quads directly. Actually, let's go with it as a field for now. I guess it's fine. It's fine. It's worked like this so far. I think I'm overcomplicating it. Yes, this is very basic. A very basic type. It's just storing the images and the geometry of where stuff is in these types. And I think we'll also we'll go back to our animation, and instead of taking a texture, we'll take an atlas. Let's actually call it a texture atlas. There we go, and then we can use the term atlas internally for the variable names. So with that, we don't actually need to then pass all of the extra info into this. This basically gets simplified down to a much more straightforward sort of class. So this that will go with atlas is equal to the atlas. We don't actually care about any of that. We just have we have our atlas passed in. All of this goes away as well. Yeah, so this is much more focused class now, right? So it's only looking at the animation itself. So in this we update the frames, and then when we draw, we'll go for maybe the atlas then has a draw method on it. So we can go function m.draw, we'll take a self, we'll take an index, and we'll take self, index, and we'll need an x and a y position. There we go. And then we'll document this, so we'll draw a sub. Draw an asset. So we've got our self, which is the texture atlas. This will be an integer. I guess these will be integers as well. Then we got love.graphics.draw. We've got our self.texture. That method is heavily overloaded, so it's picking up not quite the one we're after at the moment. But where is that? Ah, here's the animation. Okay, so then we want self.quads index, and we want x and y. We'll do a little assert in here as well. No, actually, no. I was going to say we could check that we could check the bounds of the index to make sure it's within the quads, but I don't think it's actually that important for us. Also, a lot of these we can now actually make these all private, and what private means is there are three different types of field you can have. You have private, protected, and public. Public things are accessible anywhere. So these can be accessed anywhere in an app, in the code. Protected should only really be accessed from the library, the sort of software itself. So if we were building a library, then using a protected method within the library is allowed, but not outside of the library. And private means it's just for this single this single class. So if we try and access this from anywhere else in our, if we try and access these from anywhere else in our code, other than from within the texture atlas class itself, then we're going to get told off, and we're going to get an error back. So the only things that we should actually see on the texture atlas is the draw method. So this is the only, should be the only real way to interact with this class now. So we've sort of encapsulated everything a bit, so that it's away from everything else. And with that, we're able to now go self.atlas. Yeah. Oh, I have not updated these, sorry. This is a texture atlas with frame, time, frames. Frames is also internal, so I might make that private as well. We'll come back. Actually, we'll come back to that. We don't need to look at that just now. Yeah. Sorry. Again with the side, it's always the side quests for me. Always the side quests. So if we want to draw, we can draw that, and we can go texture atlas and then colon draw, and we want to go frame.index x and y. In fact, we can actually probably just simplify, put that in line. It's not very long now, so, and it reads quite well, right? So we want to look at the frames, we want to look at the item that corresponds to the frame, and we want to get the index, pass that through the x and y to our atlas. And yeah, so that now our animation class has become a lot more focused on just the animation itself, and not on the general sort of ins and outs of how managing that large underlying image. So we can give the same treatment here to our tile set. So we'll say this takes an atlas. We'll go for the tile size, margin, spacing, image size, columns, quads. Okay, so none of that actually matters. None of that has to actually do with tiles, right? That's all a bit beside the point. And we're going to take an atlas instead. So pass our atlas here. All this can go away. So can this, and we're going to go. This also frees us up to have, by moving all this out as well, we're freeing up a load of complexity in this class, which will come in handy later when we start to look at the tile terrain stuff that we did. We started to poke at in the last that's what I'm sorry. We want to import out. For the type system alone, we want to import our texture atlas. think, oh, sorry, to the documentation. Oh. No. So we want, here we go. So lure cats is the lure cats is the lure common and type system, which defines how the typing in our editor works. So in here we want to search for at module. Okay, so that's done correctly. It's just being a bit dim. Like that. It's really not playing nice for us today, is it? Oh, hi Aaron, welcome in. Welcome in. I've just been working on refactoring some of our tileset and animation class. So we now have a texture atlas class that effectively just stores the quads that are calculated based on the size of the image, sub-images, the margins and the spacings, and can draw out one of those individual things by index. So we've got that, and then we've got and then I've used that to then take our animation class and reduce it down to some very simple logic that's all about which frame we're on when we switch over, and then we pass off the drawing to the atlas class. And now I'm going through our tile set and giving that a similar treatment. One of the things that I also learned is I was following some patterns that I'd seen other people using, but when it comes to our types, we should probably actually be doing it more like this. So we have two tables, one for our module, which has all of our class sort of types on it, and then we have a meta table which is used in our set meta table call. And in our, do we have an is? Oh, sorry. I forgot to switch back to the editor. My mistake. So yeah, I think we need to split. Beforehand it was doing this, and we were using our module sort of class as the meta table, which I'm not sure is the smartest thing. I think that's a lazy habit of others, from what I was reading, that some other people have been using, that is not the cleanest of ways of doing it. So I think going forward we're going to split them out, and we're going to have a separate meta table class for each of our things. We don't have an is animation actually. I've just noticed. So function is m.is animation. Then we'll pass a value, and we want to return get meta table of value is equal to our our meta table. And we'll fill this in. How do we name this in the other modules? It is, check type is, here we go. Check type is animation. Here we go. So that will have an is animation class there. So yeah, this is a lot more clean now. And if we compare it to the tile set, which is we're still going on. So our tile set constructor previously was, well, it had all of this in it, so it was a good sort of 40 lines long, and now we're down to 6 lines. So we'll do the same for this one as well. We're going to go local meta table is equal to a table with the index meta method value set to m, and then when we look at the meta tables, we look at our new meta table, our new internal meta table instead. Okay, so that's, and then when we come to draw, here we're going to go self.atlas draw index x and y. Colon draw, because we want to actually call it correctly. Where are we going wrong with this? So we define our texture atlas here. There is so when we try and access this in our other modules, it's not picking up. Okay. Oh, save. Alright. Cool. Okay. There was something funky going on there. It seems to have righted itself now. So this knows that it's a texture atlas. We can see it, and we know that we've got a draw method on there, and that will draw the index at the x and y positions we give it. We should probably actually no, I think these need to be numbers. I mean, at the end of the day, it's always going to be a whole number, but I want to try and keep it consistent. And I think the draw method that we're calling underneath. So this uses numbers instead of integers. I'm not sure it'd be very happy if we did pass in sort of 1.5 pixels as a position, but I'd rather be consistent than 100% correct. Okay, so we've got we've refactored those two classes, and now we'll need to refactor our main class a little bit. So So alongside these, we want to import texture atlas. And part of this, we want to go atlas equals texture atlas.new. And then our texture is, oh, is that one? And we want 32 by 32. 32 by 32 sprites. Within that, oh, this is getting in the way. And what we've sort of got ourselves to here is that we could, in theory, actually use the same atlas for everything. So we could combine these two images together and have our sprites and our tiles on in the same image, which is probably what we will do in the long haul. For now, we can get away with just passing the sprite, the atlases. Well, we can get away with having the different atlases, I think, but as time moves on, we'll start to simplify. Yeah. So if we now give the game a run, tile map newer on line 40. Okay. So in here on line 41, we are accessing the tile size of the tile set. So I think there's a few different ways we could possibly fix this, but I think we'll have a tile. I think we'll pass the tile size into the map as its own vector 2. So we have the tile dimensions in there, and then this can unpack into those. Cool. And then when we initialize the map, we'll go map data, size of the map in tiles, and each tile is 32 by 32 pixels. And then we pass our tile set in as well. And then if we give it another little run, unpack of a nil value. Okay. So we should have this, sorry, tile map line 42. Okay, so here. So we look at self.tile size. Oh, excuse me. So sorry. So what we have here is copy pasta error. And then if we give it things a run again, okay. That's a little bit weird, but it's mostly working. And yeah, as I mentioned at the start of the video, I made the tiles a bit more curved this time, so we've got more like when there's only one tile and it transitions into another, we now get a full circle, as opposed to a sort of more rounded rectangle, which is what we had before. Okay, so we've got a flashing bug now. So the tiles seem fine, but the animation is picking up a frame that doesn't exist, I think. This isn't. Okay. So atlas is a texture atlas. Atlas.draw is mapped correctly. All right. Frame. If we print the frames, then when we have then when we run the game, we should see occasionally goes to 4. No, we do have 4 frames, right? We have 4 frames, but it's the index that we care about. Okay, so let's print the index instead. So here it's 1s and 2s, I think. If we put a debugger in, okay, so when I step through this, it should, in theory, be drawing correctly. I don't see where the flickering comes from. Is it potentially an order? No. It doesn't seem to be an ordering thing, I don't think, but let's let's have a poke at the. Okay, so we've got. It was working before this, so when we rewrote the join, let's rerun this. So we should be getting. The quads through, the index. Okay, so this is tiles, I think. Hang on. What we can do is if we come into our init.lua, if we don't insert the map into the rendered objects, into our objects list, then we run things. This should only now be the sprites that get rendered. Yeah, and they're disappearing and showing. So you can sort of see which one's which by the X and Y. The index is 1. Well, the index is 2. These are. Then when we look at our quads, we have 2 values here. So if we look at self dot quads. So it should be rendering 2 at the moment, but it's not. I think it was get viewport. Sorry, colon get viewport. So this is the X. The X and the Y are wrong. I remember this now. When we were looking at things before, this was the thing that I didn't want to bother with last week, where for some reason the 2 images were rendering differently. So I think if we stop the run, we come back to our load method. We load these 2 things, and just before we actually do anything in that app, we're going to put a breakpoint in. Now when we run it, we'll stop here, and we'll see that we've got access to our 2 aliases. Sorry, our 2 atlases here. So we have one image which is 64 pixels by 13, and one that is 128 by 128. And the asset size on each is 32 pixels by 32 pixels. Okay. So then, if we look at the quads inside this, so if we look at tileatlas.quads, we get a table of quads, and if we look at number 1 in that list, then okay, so that is in the top corner, and then if we refresh ourselves on the if we refresh ourselves on that method, So this will return the X and Y position and the width and height. So X is our horizontal and Y is our vertical. So we start at 0, 0. And then the next value we have, so this is where we're going wrong. Somehow, instead of going across the image, we're going down the image. If that is the case, why do our tile sets work? So I think with that, we need to come back to our texture atlas. Yes. Oh yeah, yeah, this is this, so it should be this way around. And if we come back to the init file and we re-enable the map, then this is probably going to make something very confusing out of the map. So let's run things. So now, okay, so now it's all rendering sort of correctly, but our tiles are all wrong. But that's fine. That's kind of what we were expecting to happen just now. But at least everything else is rendering correctly. But for some reason, our tiles are a bit jumbled. So if we open our image again. So if we open the tile set, where open recent tiles. Okay. Yeah. So if we look at this, this is based on. This is the we need to set up the texture array properly. When we do that, we need to make sure these are set correctly. So what we have here is tile 1, 1, 1, 2, 1, 2, 2, 1, 2, 1, 2, 2, 1, 1, 2, 2. So this is tile, and then this is tile 1, this is tile 2, 3, and 4. So when we come back to what we have here, so this maps on correctly. This maps correctly. This one is also correct, right? So 1, 2, 2, 1 is 2. 1, 2, 2, 1 is 2. 2, 1, 2, 2. 2, 1, 2, 2. So the mapping here seems to be correct. But it doesn't refer to the correct quads, which is curious. So if we come back to the, if we look at our tile atlas again, we'll put a breakpoint in there and run things. So our tile atlas, we have quads. Tile 1 is at 0, 0x, 0y, and is 32 by 32 pixels. Tile 2 Why is this backwards? I'm doing something really stupid somewhere. Ah. No, I'm looping. I'm looping in the wrong order. Okay, yes. Okay. So because the other one was because the other image was only one row of sprites, it didn't make a difference. Because the tile set is a larger image and has 4 columns and 4 rows, and we were looping in the wrong order. So we want to go row by row and column by column. And then if we run things again and we start to poke at this, okay, yeah. So our first one is our first image is at 0, 0. Then our second one is at 32 pixels from the left and 0 from the top. And then our third and fourth further along the first row, and then when we get to our fifth, we go down to the next row. Okay, that makes more sense. That's what we're after. So now if we run it, there we go. Yeah, we're back in business. Everything is working as needed. Cool. Okay, so that, yeah. So we've tidied up our sprites and sorry, our animations and our tiles now. So when we come back to our monster init file, init.lua file, and our giant load method, we have the initialization of our sprites in this still. So that we probably want to move out into its own thing. We also have the mappings for our tile data, which we probably want to put somewhere else as well. Yeah, resist puns. Let's keep it PG in here, please, Aaron. I had to choke the giggle back there myself when I realised what I was saying, but yeah. Okay, so I think what we want to do now is try and move our game objects into their own sort of things rather than having them all defined in our load method. So we're going to have an objects. We'll have an object folder, and in here we'll have a player.lua and a slime.lua. And I think these will I think we'll have those. We'll set these up as is, and then there's a bunch of stuff that is mirrored between them. that we should have a think about. Because one of the things we don't want to do is have everything in a giant sort of model. We're going to try and have and sort of the same thing in multiple places. So we should try and carve up the existing ones into more sort of sub pieces. I think part of that is that so they have a position and velocity. So one thing I'm sort of struggling with is that a lot of the logic, say, between our player slime here and the NPC slime here is pretty much repeated, right? So we move it the same way, we animate it the same way, we draw it the same way, based on the fact that it has a position and a velocity and an animation. So we kind of don't want to have the whole thing, all of that logic repeated, and we probably don't want to have it all sort of spread around too. Oh, there, sorry, I've just noticed the camera was flickering quite badly there. There we go. We don't want to have it. Can you write some dialogue for NPC slime? No, because the NPC slime is probably gonna go away very soon, become an enemy slime eventually, but it will come back as an enemy. But for now, it was just the simplest sprite I could think of for drawing. And I'd read that time I was reincarnated as a slime manga that morning, so it was on my head. It was on my brain at the time. But yeah, the play. It's a lot of this is most of this is actually going to change. We're just at the moment it's about getting the building blocks in place so that then we can start to actually flesh something out a bit more solid. So if we look at this stuff, trouble we have is the standard sort of way to no, that's so the standard way that you would have in an application a lot of the time is you'll have a hierarchy of classes. So so you might have it's a bit bigger. So you might have like you might have a person, and a person. Person implements, I don't know, monkey. Which implements. Oh. Which implements animal, which implements life. which implements life forms. So you have like a chain of how things is going from more abstract to more concrete, and then you'd have it within the classes, and then you'd have instances of the person, which would be the individual people themselves. But what we have, problem we have is we have instead of having that, we've kind of got a few different types of things, right? I'm not quite sure how they stack together. So we have a movable. We have a drawable. Oh, that didn't quite fit in. And we have our sort of our player and our NPC. Oh, sorry. So both of these sort of implement these, but they're not. There's no sensible hierarchy of movable and drawable, right? They're interfaces. They're sort of and there's not a sensible sort of. There's not really a good multiple inheritance system in Lua, because as I said, in a lot of languages you have sort of A, B, C, and D, and the flow is like this. Python, for instance, is nice in that you can have like A, B, and then you could also have C, and both of these come into D. And it could even sort of spread out in diamonds and stuff. So, which is sort of mixed in or trait based design. So I'm wondering how we can get that in Lua, which is a lot less straightforward. So I think we could kind of have all of the sprite logic in one giant nasty class for now, and then we could go with a giant nasty sort of class that has all of the logic in. I don't really like that as an approach, but we could then inspect the various types of thing that it has. So if we or we make our objects dumb and we have the logic outside, which could also work. So this would mean that let's define a new module, index. Oh. Index equals m and then function m.new pass in a name, and we'll go local self equals to a table with name equals name, return set meta table self to empty, and then at the bottom of this we return the module. So what I'm thinking is we create an object, and then what we have is a function has then what we're having here is another traits. I have a traits table on this as well. And then we will define this as has. Define a has method, and we'll go self.traits trait is equal to object. No. Hang on. Oh, I'm missing self there. So we'll also define a has function. And we'll go for underscore trait in ipairs. Okay, for each, so what this will do is loop over every value in the by using dot dot dot. We're saying instead of having one parameter, we can have any number of parameters, and they'll all get added to this variable called dot dot dot, and then we'll loop over everything in there. This will give us the index and the value. We don't care about the index, so we'll set that to an underscore. And then if then we want to see if a table has a key. Which just thinking is going to lure. So we want to check if a table actually has a key and if the key is present, because in Lua, if you try and access it and it doesn't exist, it will return nil. but it'll also return nil if it's actively set to nil. But we don't want to. But we want to allow false values. So we can't just go if the value is false. All right. I guess there's no actual method for checking, so we're just going to have to go with if self dot traits trait is not equal to nil, then we return. So if it is equal to nil, then return false. And then if it is, then we return true. So then this will mean that we will be able to take our object and we'll be able to go x equals x dot add position vector 2 dot new a like 1 and then we'll be able to do stuff like x dot has position. So I'm thinking we have fairly loose objects, and then we act on them based on what the traits that are attached to them are. So m.new, yeah. Okay, yeah, and then our player here becomes object is equal to require crawler engine.object. M is equal to an empty table. Then we go function m.new. This will have a name, and we'll go object.new name. Just have an X and a Y as well, I guess, for player. And then we'll go object.set position to position local local vector 2 is equal to our vector 2 module. We'll set this to a vector 2 for x and y. We'll say it's if we look into the if we look at the sprite that we had, okay, if we can break this logic up now, so then we can have a look what actually went into this. So we had a velocity which started at 0, which was 0, 0. We had the position, we have speed, and the speed we had set to 100. We had the animation. Here we go. So we go animation to we can pass in the atlas. We don't want to copy the methods for now. Okay, so given that, yeah. So what we're doing here is we're composing the object of parts. So each of these is sort of a trait. So it has an animation trait, which means it has an animation attached. It has a position and a velocity and a speed. And then I'm also going to do I'm just going to set that one to true. Oh yeah, I'll set that to true. And here we can return M. And then when we look at the slime one, this was very similar in a lot of respects, but I think we gave it slightly different animation for. Oh, sorry. Yeah, we gave it slightly different animation, and its position and velocity were different. So this was 200, 400. We'll not set. Actually, we won't change that. And then the velocity. What am I looking at? Ah, this one. Sorry. And then the velocity was 50, 50. This doesn't have input. Okay. Oh, I'm messing with the window sizes again. I'm sorry. Yeah. So this one has these are basically the same in a lot of respect, except for the one has input, one doesn't. And then to reuse the logic, now we have two factories now that can return these. So if we go back to the init, we can I think this is where we then also can go that we have a world. If we have a world.lua, and we define that as local m equals our standard module setup. So if we then define the world as m.new, we can return a local self is equal to, and then we want to have objects. And we'll say handlers. And then we'll have a function m.on self, and then we'll have an event of traits and a callback. Callback, and then we'll have params. Of a param for now. And then, okay, we'll register. Oh no, sorry, that's not on here. What we'll do here is we'll go on. We'll go self dot if self dot handlers dot event is nil, then self dot handlers event is a new table. So we're going to have a nested table for each event, and then in that we'll go table insert self dot handlers event. We'll add a new table which will be traits is equal to traits. Callback is equal to callback, and then we'll have a function to trigger events. I'll have self event traits and a param, and what we'll do here is we'll go if self dot handlers event is equal to nil, then return, because there's nothing for us to do here. Otherwise, for item in the IPERS in the handlers, do sorry, for each object So for every object, we want to loop over the handlers. Yeah. And if the object has the traits, then we call the if the object has the item.traits, then we call the then we call the item.callback with the object and the param. So we want to loop over each of our objects, and for each object we want to loop over the handlers for that event. And then if the object has the traits that the handler was registered with, then we call the callback with a parameter, and that gives us our things. Then we want to have another function here to register our objects, and we just want to go object, and with that we just want to go self.object. We want to go table.insert self.objects, and we just want to insert our new object. And that is m.register. So this is like this is going to be the brain of our game. This is the world class. And then, so we're going to return the we're going to be create a new world object, and this is going to have both objects and handlers. Handlers. There we go. And we're going to set that as we're going to return our new world class world object here. On that world object, we're going to be able to register our objects, and it will keep track of all the objects that we have in the game. And we're also going to have we're also going to be able to register a handler for a specific event for a specific set of traits, and when and that handler is a callback. So if we don't have a slot in our handlers array for the event, then we create one. We create a new table in there, and then we insert into that table the a new sort of little table here with the traits and the callbacks ready for us to use later. And then when we trigger an event or a parameter, we cancel early if there's no handlers for that event. But if there is, then for each of the objects, we look at each of the handlers that are associated with that event, and we call it if the traits match. And we allow a parameter to be passed in. So this parameter is going to be our delta time for an update, and then for draw we won't really have anything, I guess. Which means in here now we can go local equals require we should only ever need one world as well, I think. I'm just trying to think how we name this, because we probably want to call the variable world, so we don't want to call the import world. Let's leave it a world. We'll name this with a underscore, I guess. And we'll set the type of that to world. In our thing here, we'll set the type of this as a world as well. So it's we at class world. So this is a world class now, and then in our load we will go underscore world is equal to world.new and then we want to import our objects as well, I guess. And I think we'll do that in here. We'll go create a variable there, and we'll go m dot player equals require the player m dot slime equals require we'll cry the slime. So this is just going to be a little container module that imports the others for us, which means we don't actually have to import everything at once, everything independently. So we can go objects equals require we can go objects equals required object or object even, and then down here when we can register things, we can go so we can register a new player, call it player, the sprite atlas, and we initially said the player is at 400, 300. Okay, so that effectively gets deals with that. Then we can register the other we can register the object.slime.new as slime. I guess the sprite atlas as well, and we initially they're at 200 and 400, so they're further down in the world. Oh, sorry. Yeah, we sort of put the underscore afterwards, didn't we? So we can close that off. And then if we make the world respond to update and so now if we give this an update method and we take self and dt, it can go self trigger, and then this is going to be update, and it's going to be dt. And then we'll have a draw method which takes self, and this will just pass nil as our parameter. So we have both of these methods, and then we can put the world into our objects instead. So this is local. This is still a table. Put this back for now. And we'll go objects dot, sorry, table dot insert objects, and we'll put the world in there. So in fact, we don't actually need that outside of our load. So that can also be a local. So we'll actually make that a local variable. Sorry, so this needs this should be colons. I will eventually get used to this syntax. It's a weird sort of Lewis specific thing. Yeah, so that gets rid of all of that logic, and then in here we can start to now attach some events. So on an update of something that has a position and a velocity, we can assign a new event, a new handler, and this will have the object and the dt. And when that happens, we can go, where is our object class? Yeah, we missed one function here. Actually, I don't need the objects. Don't need the objects. do this in the world itself. Where's this? Undefined field handlers. I've just realized. So what we have here is a command dispatcher pattern, which is normally a message bus. So if we go over command dispatcher, why does this lose the... Oh, it's because I don't have it defined up here, isn't it? Handlers is... handlers is traits, which is a array of strings, and a callback, which is a function with hi Kongville, welcome in. The coding today is going well. So at the moment I'm just trying to work out how we can get all our game objects sort of moving around and updated without having to keep repeating the same code between each object. But so we're sort of looking at a little sort of event bus that can map the various things that are happening within the game and map those onto the individual objects. Yeah, we've done a lot of simplifying today, which has been quite nice. And this is actually a table of string to the. This is actually okay. This one's actually a table of string to an array of those objects, and the objects is a big bag of stuff. And oh, there we go, it's all stopped moaning at us now. So I think if we register the objects into the system, and then we can look at them for events, and then we can trigger we can trigger the events on them, and then for update and draw we'll trigger those events, and that should what we have here is a basic command dispatcher. So if we come back to our main file, that's now the bus. Let's call it a message bus here. Which is the more correct name. We'll go, and then in here we'll use the abbreviation for the variable. So here we go. So we have bus is equal to the new message bus, and then we register our stuff with that, and then on here we update our sprites. It can look a bit confusing, but what you sort of have to think about when looking at code is it's another language, and although it's mostly English, it's a very specific set of English. But all it's really doing is describing stuff and giving instructions. And if you can wrap your head around that bit, then the rest of it starts to slowly fall in place. So I think this should, in theory, be mostly there now. We also want to have a bus stop on. Oh, hang on. I remember what I didn't update. We were going to update this so that instead of has, we'll have a local run equals true, and then for trait in item.traits, do if object trait is equal to nil, then we'll go run equals false, and we'll break, which means we'll stop the for loop. And then if we run it, then run's probably a bad name. So if it matches, okay. Yeah, so if it matches, we'll assume that it matches at first, and then if any of the traits that we're looking for don't exist, then we'll say it doesn't match. Oh, and thank you, Conville, and have good luck with your stream. What are you actually streaming today? Do we have a link for Conville? We do. Yeah, so we'll have a look and we'll see what matches. We'll assume we will go over each. We'll look at each handler for each item. We'll look at each handler, and we'll just assume that it matches to begin with, and then we'll look at each of the traits, and we'll see if we have a property on our object that matches that trait. And if we don't, we're going to set it to false. And if we have one that doesn't match, then we're going to exit out of this for loop early. And that will allow us to then look at that matches property, and then if it does match, then we're going to call our callback. So now when we go on, so now if it has a position and a velocity property, then we can update things. And then if we have, for an update, if we have This one, if we go on, if it has animation, then we can give it a function object dt, and if it has an animation, we can go object.animation.update, and we can pass in the dt there. Oh, that should be a colon. Yeah. So we've got so we can slowly build up our logic here in these little handlers, so that they will basically act upon anything that has the properties that we want. So if it has a velocity and input, which we set on the player, then we can use our input handling that we defined before. So we go so it's as velocity, speed, and input. If it has velocity, speed, and input, then we can set this up the same as we did what am I doing? Object dot. Yeah, we set the velocity and then we set the object's velocity to the normalized value times the speed. So now we're abstracting away the processing of this. So based on the features that the thing has. So now we instead of defining all of our objects, we define them in their own little sort of factories here. Instead of it being like this, we go we'll make these nice and simple. Position. Position, velocity, and input equals true. Yeah, these can be standard little basic objects now. They don't need to be anything complicated. Oh, missed the comma there. We could do the same with the slime one, which is almost the same as this one, actually, isn't it? So we can just take this and copy paste it across. The only thing that was different was the velocity is 50-50 instead of that, and it doesn't have the input at the same speed. Okay, so we've got, I think we've got something quite powerful here, actually. So we have our objects, we have a player object and we have a slime object. They have they're tables with these various properties on them. And then we have our message bus, which will route events that happen through to those through to those classes, those objects. And then in it we set up some handlers, and we say, okay, based on the properties that something has, so if it has a position and a velocity, then we'd update its position based on its velocity. If it has a animation, then we update the animation. If it has an update, sorry, if it has a an input, then and velocity and speed, then we update the velocity based on the speed and the keyboard input. Oh, I just realized that we also need to bus stop. We need to register some draw methods as well. So we want to draw anything that has an animation and a position. We want to call a function the object, and then we will go object dot animation dot draw object dot animation dot draw and we're going to do that object dot position dot x and object dot position dot y. So now if we run things, we're going to have a load of bugs that we can work through. So first up, on line 36 of our new message bus, 36 is here. We want I pairs across the traits. So if we run again, what do we get now? In attempt to index field position of a nil value. Okay. So when we trigger the draw method, it's finding something that matches. Call it object dot. Why is this different to our update ones? Is the missing parameter there? Let's see if that makes a difference. No. Let's try again with a breakpoint. Okay, so that one is, it's not that one that's erroring for. Sorry, it's here. So we called that was our error. We were referencing the global object instead of our input object. There. So now we have, okay, so this is, we're able to move around. So what happens if, but we appear to have lost our We appear to have lost our sprite. Oh no, there it is. So we're back to where we were, effectively at the start, but our code is a lot more tidy now. So we have these sort of handlers here that process different events, and based on the attributes that are present on the different game objects, it will decide whether or not it processes them or not. Which means that we can look at the sort of shape of things, the shape of our various objects, and then we can apply the logic, which means that the logic sits here, and then we have these really simple little game objects instead. Like our player, and it's just, these are just informational now. There's no behavior in them. And the slime is the same. The behavior has all been moved externally. This is not used anymore. So yeah, I think we've got things to a much more sensible. I think this is an interesting structure. I'm wondering how we can get the map engine itself into the same system. So this is effectively just responding to the same sorts of events, but but I think we can eventually refactor our map itself to live within the system. All that I guess we have left now is a little bit of tidying. So yeah, so we have a message bus class, which is a message bus, and this is a it's an implementation of a command dispatcher pattern, which means that it takes commands like the events that we have here, and it routes them to some sort of handler, which is our callback, via its internal logic. We have a factory for these. So this is a message. Message bus factory, it returns a message bus, a register method. This takes a message bus and an object. This will register a game object with the message bus. We have register the on method, which will register a handler with the message bus. So this has an event, which is a string, trait, which is a array of strings, and a callback, which is a function, which takes an object, any, and a param, any. We have a trigger method. This takes an event, which is a string, and a param, which is a any, and that triggers the handlers. And this is just a shortcut for a shortcut for the update event, which takes a number, and this one is a shortcut for the draw event. Okay, so we've got our message bus. Our message bus here. We've got our player and our slime. Let's set this as a class. An animation param, a speed param, which is a number. It has a position, which is a vector 2. It has velocity, which is also a vector 2. And it has an input, which is Boolean. Okay, and then we've got our slime. Which has most of that, but doesn't have the input. I think that's everything in a good place now. On this one. Oh. Oh. Actually, there's no, this is not attached to the this doesn't attach to that, does it? So actually this lives on the new, and it's in the return. It returns a type that has all of this stuff in it. There we go. So I need to see if there's a cleaner way to define this stuff. Yeah, it returns this more complicated type. And I really do not seem to be able to type today. Alright, I think this is actually probably a good place for us to leave it for today. But yeah, so we've got, or actually no, hang on, we'll do the player as well. Here we go. So we'll define what this returns. Define what this returns. And we want to define the params as well, I guess. Param. There's a texture atlas, and param x is a number, and param y is a number. So now we've got, here we go, slime. We have a slime factory, and we have a player factory. Now, okay, yeah, I think this is a good place to leave it for the day. So what we've done today is we abstracted stuff away. So all of the common code that was shared between our tile set and our animation is now moved away. So this is all made a bunch more simple now. So we literally just take the atlas for the animation. We say which frame we're on, what the current time offset is, and we keep an index of our frames. Each frame has an index within our atlas and a duration in seconds. Then as we update, we advance the frame based on the durations, and then eventually we wrap around to frame 1 if we run over. And then when we draw, we take the index of the current frame and we draw that out with the x and y. The same with our tile set. Our tile set now, we have just the atlas and the terrains, and then we do the weird logic that we came up with last time to find the tile index based on the terrains, and then we go to our atlas again and we draw what the index we decide on our x and y, and all of the logic around how we break up the tile, the texture atlas is in this new class, and that will gives us a draw method where it will take the index and the x and y, and it will pick the section of the texture based on that index, and it will draw it at the x and y provided. We also moved all of our sprites into a new set of game objects, So we have our objects, we have a player object and our slime object, and then based on the values that we pass in here, so based on these properties, they will get processed in different ways now, and that will happen in our new message bus class. So if we look at our init again, here we now have our message bus, and we register our different objects with it, and then we associate different bits of logic to different events based on the properties that are available. So if it has position and a velocity, then we move it by its velocity. If it has an animation, then we advance the animation by the amount of time. And it has velocity, speed, and input, then we update the velocity based on the user's input into the keyboard. And that will happen every time the update cycle runs, and then every time the draw cycle runs, we will take everything that has an animation and a position, and we will draw the animation at that position. And therefore, if we want to add a new object that moves, so any new object we create that has a position and velocity will move. Any object that has an animation and an animation will get drawn, and anything that has an animation and a position will get drawn at a specific place. So when we come to actually defining the objects in our game, we just have to define the data around them, and the engine itself should pick up the logic that needs to be applied to those objects, which I think is fairly cool as a way of structuring things. So I think I will, as I said, I think I'm going to leave it here for now. If you like the video, give it a thumbs up. And we will be back next week on the Sunday, I believe. Yes, so we'll be back next Sunday, back to our regular day and time slot on the 29th for another game dev stream. And then that will probably be our last stream for a few weeks, as I will be traveling, and then we'll be back again after that on the 26th of January. Sorry. And if you would like to catch up with where we're going in the future of this, then give the channel a subscribe, mash the notification bell, and I will see you all in the next one. Bye.